Okay, good morning everyone. Today I'm going to discuss about the grid and cloud computing subject, Unit 4. So coming to the topic, that is Unit 4 topic is programming model. So in this programming model we having different contents, that is open source grid middleware packages, next Globus Toolkit architecture, so in shortcut we can say GT4, and next configurations and usage of Globus, main components and programming model. So these are the contents we are going to discuss in this programming model. So coming to the first topic, that is open source grid middleware packages. So what is mean this? Many software, middleware and programming environments have been developed for grid computing over past 15 years. Okay, so we first introduce in this we first introduce some grid standards and popular application programming interfaces. Then we present the desired software support and middleware developed for grid computing includes 4 grid middleware packages. So in this section we first introduces the application programming interfaces, that is a popular and standard grid application, and in this we are having some software support and middleware developed with the grid computing includes 4 grid middleware packages. So okay, so in this grid software support and middleware packages are there, and that is called Bionic, Unicore, and some Globus GT4. So these are the different and 4 middleware packages are there. So before going to discuss that 4 packages, so in this we having 2 well defined organizations, that is Open Grid Form, OGF in shortcut. It mainly used for connectivity and for the users, developer and vendors for grid computing. So this is called the Open Grid Form. Next, object management. These are the 2 well defined organizations which is used in the open source grid middleware packages. So what is mean by middleware? So middleware is called a software layer that connects software components. It lies between the operating system and the applications. So this is called the middleware. So what is mean by grid middleware? So a grid middleware is nothing but a layer between hardware and software, the sharing of heterogeneous resources and managing the virtual organizations created around the grid. So this is called the grid middleware. Okay, so in this grid middleware we told that we having some popular grid middlewares, that is Bionic. Okay, so coming to this one, so this is Bionic. In shortcut we can say it is a BOINC. So Bionic, so this full form is Berkeley Open Infrastructure for Network Computing. Okay, so in this we having the Unicore. So Unicore is a open source. It is a uniform interface to computing resources. It focuses mainly on high level programming models like Java on Unix. So it developed by the German grid computing community and a ready to run grid system including the client and server software. So this is called the Unicore. Okay, so Berkeley Open Infrastructure for Network Computing is high performance distributed computing platform. Okay, so this is called Bionic, and Unicore we have seen now, and this is the uniform interface to computing core. And coming to the Globus GT4, it is a open source and it focus mainly on low level services like C and Java on Unix, and it is a library jointly developed by the Organic National Lab, and it is the University of Chicago and USC Information Science Institute, founded by DARAP, NSF and NIH. Okay, so it is open source toolkit for grid computing. So NIH means National Institute of Health, and NSF means it is a National Science Foundation, and next DARPA means Advanced Advanced Research Project Agency. So this is called the 3 different institutions we are having. Okay, and it is a open source toolkit for grid computing. So this is the Globus GT4 open source. So what is mean by popular grid middlewares ma? Bionic we are having. This is called a Berkeley open infrastructure for network computing. It is having the high performance distributed component computing platform. And next one is a Unicore, and Unicore is nothing but open source, and we having it is a uniform interface to computing resources. Next it mainly focus on high level programming models like Java and Unix, and it is developed by the German grid computing community, and it is ready to run the grid system including the client and server software. So this is called the Unicore. Next, the second one is a Globus, and this is in shortcut we can say it is a GT4, and it is also a open source. It mainly focus on low level services like C and Java on Unix. So its library jointly developed by Organic National Lab, and it is the University of Chicago and USC Information Science Institute, founded by the Defense Advanced Research Project Agency, National Science Foundation, and third one is a National Institute of Health. These are the different institutions we are having. So it is a open source toolkit for grid computing. Okay, so next grid bus. It is also a open source. It focus on the abstractions and market models on Java and Unix. It supports e-science and e-business applications. So Legion means it is not an open source. It is not an open source, and it mainly focus on high level programming models like C++ on Unix. It was the first integrated grid middleware architectured from first principles to address the complexity of grid environments. Okay, so next coming to Globus GT4. So what is mean by Globus GT4? So in this Globus GT4, a middleware library jointly developed by Organic National Lab, University of Chicago, and we have said that USC Information Science Institute, founded by the Defense Advanced Research Project Agency, National Science Foundation, National Institute of Health, and CGSP in China Grid. So what is mean by CGSP? It is a China Grid support platform, is a middleware library developed by 20 top universities in China as a part of China Grid project, Okay, and in this we are having the Condor G. Condor, what is mean by Condor G? So Condor G is originally developed by the University of Wisconsin for general. Who it is developed ma? Wisconsin. Wisconsin is developed the this university. Okay, and so it is originally developed by the University of Wisconsin for general distribution computing, and later extended to Condor G for grid job management. Okay, so here Condor can be derived using the command line tools. It is used for command line tools, and we have Condor submit, Condor queue, this like. Okay, so what is mean by Condor submit? Which allows to submit the jobs to the system. That is called the Condor submit. This is the example of the Condor G, and another example is Condor queue, which allows to query the state of jobs in pool. So this is called the Condor queue. So these are the examples: Condor submit, Condor queue. Also these are the examples of the Condor's command line. Okay, so next in this we having Sun Grid Engines. Sun Grid Engine SGE. It is developed by Sun Microsystem for business grid. It is developed by Sun Microsystem for business grid applications. So it applied to private grid and local clusters within the enterprises or campuses. Okay, so enterprises and campuses, and in this we having grid standard and application programming interface. So in this application programming interface, grid standards have been developed over. Grid standard have been developed these grid standards and programming application programming interfaces is it is a grid standards have been developed over the years. The open grid form and object management group are the two well-defined and well-formed organizations behind those standards. We already introduced the OGSA in standards, including the glue for resource, including the glue for research resource representation. So SAGA means a simple application programming interface for grid applications, and GSI is nothing but grid security infrastructure. OGSI means open grid service infrastructure, and WSRE means web service resource framework. So these are the different representations, resource representations is introduced here. So okay, and next in this research, in this grid standards have guided to develop the several middleware libraries and application programming tools for grid computing. They are applied for both research grids and production grids today. So the research grids tested including the France grids and D grid German, CN grid China, Terra grid USA, etc. So these are the different grids introduced, tested in the tested by the research grids, and the production grids built with the standards include the including the EGW INFN grid Italian, and Sun grid Tequila, and X grid. We review next the software environments and middleware implementation based on these standards. Okay, so these are the grid standards we have developed in the several middleware libraries. Okay, next software support and middleware. Software support and middleware. So what is meant by software support and middleware? So in this software support and middleware, we having the grid. Grid middleware is specially designed a layer between hardware and the software. So grid middleware is specially designed a layer. Grid middleware is specially designed a layer between hardware and the software. So this middleware product enables the sharing the heterogeneous resources and managing the virtual organizations created around the grid. Okay, in this middleware glues or allocated resources with specific user applications, and popular grid middleware tools include the Globus Toolkits, that is USA, GLite, UNIT-4 German, Bionic Barclay, and CGSP China, Condor G, and SunGrid engines. So these are the popular grid middleware tools which is used in the Globus tool. Okay, next. In this the grid software support and middleware packages developed for grid systems since 1995. So this in this section we describe the features of the Coder G, that is SGE. SGE means we have seen here, SGE means Sun Grid Engine, and GT4 Globus Toolkit 4, and CGSP. CGS means China Grid okay, and CGSP. Okay, this is the China Grid Support Platform. So these are the different popular grid is used in this software support and middleware. Okay, and so next coming to Globus Toolkit architecture. So up to here we discussed about the open source. So open source grid. So what is we have discussed? Open source grid middleware architecture. Open source grid middleware package. So next coming to software, Globus Toolkit architecture GT4. So this is the next topic. So in this Globus Toolkit, it is an open middleware library for the grid computing communities. So these open source software libraries support many operational grids and their applications on the international basis. So in this Globus Toolkit architecture, we having some library. We told that in this Globus Toolkit, we having some open middleware library for grid computing communities. So these open source software libraries support many operational grids and their applications on the international basis. So the toolkit addresses common problems. So whatever the toolkit we are using in this GT4, the toolkit addresses the common problem and issues related to the grid resource discovery, management, communication, security, fault detection and probability. These are the different things addressed by the toolkit in the grid resources. Okay, so grid resources, and the software itself provides a variety of components and capabilities. The library includes a rich set of services implementations. The implemented software supports or grid infrastructure management. It provides tools for building new web services in Java, C and Python, and it builds a powerful standard based security infrastructure and client application programming interfaces in different languages. So it offers some comprehensive command line programs for accessing the various grid services. Okay, so the Globus Toolkit was initially motivated by the desire to remove the obstacles that prevent the schemeless, and in these collaborations and sharing the resources of services in scientific and engineering applications. So these the shared resources can be computers, storage, data, services, networks, science instruments, examples or sensors and so on. So the Globus library version GT4 is conceptually shown in this diagram, figure. So this is the diagram of the Globus Toolkit architecture GT4. In this we are having applications. Next high level service and tools. Next core services and local services. So what is mean these these things we have seen in this diagram. So GT4 library. So library standards, services implemented. So here we are implementing some software support grid infrastructure management. It provides tools for building a new web services in Java, C, Python, and in this Globus Toolkit. So here we are having some applications. See this one. So applications we having in the first service. Next coming to the high level services. So what is mean that? Okay, so we are having here. So in this toolkit, in this Globus Toolkit, it has layers. At middle layer we have core service and grid grid applications in this, and in the at the second layer we have high level service and tools such as MPI and Nimrod, G Coder G. These are developed by the third party for general purpose of distributed computing applications. And at the bottom layer we are having the local services such as LSF, TCP, UDP, transport control protocol, UDP, user datagram protocol, Linux, Condor. So there are fundamental tools supplied by other developers, and this GT4 is based on industry standard web service technology. In this we having some functionalities. In this that is Globus resource allocation manager, DRM. So what is in this we having some abbreviations, DRAM. So what is mean of that? Globus Research Allocation Manager. It is grid resource access and manager. So next to communication. So unicast and multicast communication and grid security infrastructure. So this is the functions. So in this we having library, GT4 library. So in this Globus Toolkit 4, it provides some components in the following 5 categories: common runtime components, security, data management, information service, execution management. These are the GT4 libraries. In this we having some service functionalities, that is global resource allocation manager. So GRM, so not DRM, GRAM. So this is a grid resource access and management. This is a HTTP based, okay, and HTTP based. This is the next one. Coming to communication. So in the communication we use NISX, so unicast and multicast communication, both one side and multi sides communication will be occurred. And next grid security infrastructure, GSI, and it is authentication and related security services. So what is the main use of this grid security infrastructure? It provides the authentication and it provides the security, okay, to the services. Next monitoring and discovery service, MDS. It is a distributed access to structure and state information. So this is the one section. In the another section we have health and status, HBM. HBM is nothing but heartbeat monitoring of the system components. So how the HBM is in the medical, I mean in the scientific in the science side, how the body of the human body we are going to monitor regarding their health issues, anything. So that like only this HBM is nothing but heartbeat monitoring, that will be completely monitor the system components, how they are working, how they are solving the problems. Everything will be monitored by the heartbeat monitoring of the system component. So next to global access of secondary storage, GASS. So it is nothing but grid access of data in remote secondary storage, okay. So next coming to grid file transfer. So grid file transfer, in the name only we can understand how to transfer the files. So grid FTP means inter grid FTP, okay. So its explanation is internode fast file transfer. So while using this grid FTP, it is mainly used to transfer the files very fast, okay. So this is called the functionalities of the Globus Toolkit 4, okay. So in this Globus Toolkit 4, we offer some middle level core services in grid applications, the high level services and the tools, and tools such as MPI and Coder G and Nimrod G are developed by the third parties for general purpose distributed computing applications. So these are we have discussed now only. So local service, LSF, TCP, Linux, Coder. So these are the bottom level of the fundamental tools supplied by the other developers. And NISX is used for collective communication, and a HBM means heartbeat monitoring for resource nodes, okay. So grid FTP is a speeding up the inter-node file transfer. The module GASS is used to global access of secondary storage. GSI is a grid security infrastructure. So it is used for providing the authentication and security for the services. So this is called the GSI, grid security infrastructure. So next coming to Globus job workflow. Globus job workflow. So in this I have diagram. So in this we having typical job workflow when using the Globus tools. So a typical job execution sequence proceeds as follows. the user has his credentials to the delegation services. The user submits a job request to GRAM. It is nothing but we have seen now only here. So what is mean by GRAM? Grid Resource Access and Management. So what we are saying that, so grid resource access and management, the user submits a job request to for whom, so GRAM with the delegation identifiers as a parameters. So GRAM means GRAM passes the request and retrieves the user proxy certificate from the delegation services and then acts on behalf of user. So the GRAM sends a transfer request to the RFT reliable file transfer, which supplies grid FTP grid file transfer protocol to bring the necessary files. Okay, so if you see the diagram, we can understand very clearly. So this is the SEG, and in this we are having the so here we having the client. The client will be submit the job request to GRM. GRM means we have seen now only, that is grid resource access and management. So the client will be submit the job request to the GRAM service, and after that what he will do, he sends to the adapter. So the request is sent to the GRAM adapter. After that, the GRAM adapter will be send the request to the user job, and after sending that request to the user job, and the GRAM sends so if I have the transfer request to the RTF means here this is the, so what we are saying that the GRAM, here we having the explanation about this diagram. So the what the user means client will be submit the job request to the GRAM and with the delegation. So with the delegation and identifiers as the parameters. So the GRAM passes the request and retrieves the user proxy and user proxy certificate and from the delegation service, and then acts as a behalf of user. So GRAM sends, so this GRAM sends a transfer request. What he sent, transfer request request to the RFT. This is the RFT, and this is the reliable file transfer which applies grid FT. It applies, it sends to the grid FTP to bring the necessary files, to bring the necessary files from the storage elements. Okay, elements list. Okay, this is the grid FTP. In this we having some remote storage element list. So whatever the files we need, we can access that files through the grid FTP. Okay, so this is the interactive functional modules, and in this so GRAM, so grid resource access and management invokes the local scheduler via GRAM adapter. So here we having the GRAM adapter and SEG scheduler event generator. So these two options we are having here. Initiates a set of user jobs. It initiates the set of user jobs. The local scheduler, here we having the local scheduler. So this local scheduler reports the job state to the SEG. SEG means what? Scheduler event generator. This local scheduler will be reports the job state to the SEG. To SEG means schedule event generator. Once the job is complete, so the GRAM, it means a grid resource access and management, uses the RFT reliable file transfer and grid FTP to stage out the resultant files. The grid monitors and progress of these operations and sends the user a notification when they succeed, fail or delayed. Okay, so this is called the explanation of this diagram. So this diagram is called the Globus complete element and Globus job workflow among interactive functional modules. Okay, so this is called the workflow Globus. Okay, so next coming to configuration. Okay, so this is the once again I am just recollecting the points of this diagram. So this is the GRAM. So this is the GRAM service. So client will be submit the job request to the GRAM. So the GRAM including with the delegations, it will be including the delegations. So what he has said, so in this GRAM uh, with the delegation identifiers as a parameters, the GRAM passes the request and retrieves the user proxy certificate from the delegation services, and that acts as the acts on behalf of user. So this GRAM sends the what he sends this sends the transfer request to the RFT. So this GRAM service will be send the transfer request to the RFT. The RFT sends to the grid FTP. So why he sends to the grid FTP? So according to the grid FTP, so what which applies whatever the necessary files you need, you can bring from the remote storage element list, that is grid FTP. Okay, so after that we are having some local scheduler. So SCG and GRAM adapter, these are the two other two other user jobs are there. So the local scheduler, this local scheduler will reports the job state to the SCG, and this after once the job is completed, the GRAM uses the GRAM use RFT and grid FTP to stage out the resultant files, and grid monitors to the progress and this operation and sends the user user notification when they are succeeded, failed or delayed. So whatever may be occurred, if the information is succeeded, transmission is succeeded, or either failed or either delayed, whatever may be, it may be submitted to the user. So this is the working of Globus workflow. Next coming to configurations. So what is mean by configurations? In this we having installing Globus Toolkit 4. You may install Globus Toolkit 4 in many ways. So in this section we introduce both binary and source package installations, and installations of the binary packages is extremely fast, while installation using the source package will take longer as would be expected, and this is expected. And in this installation this is called the installation Globus Toolkit 4. Next coming to installation from binary package. So we told that we having some binary package installation from binary package. So we have to install from a binary package to obtain the Globus Toolkit 4 binary package from the Globus site. So we have to second is we have to take to extract the binary package as a Globus user, and we set the environmental variables for the Globus location, and we have to create and change the ownership of directory for user and group Globus. And fourth one is configure and install the Globus Toolkit 4. So this is the package of binary. Okay, and next coming to configuration and texting of grid environment. So after installation of Globus Toolkit, so whatever the installation steps are there, after following that installation step of the Globus Toolkit, each element of your grid environment must be configured. So that is called the configuration and testing of grid environment. Next one is configuring environmental variables. So before starting the configuration process, it is useful to set up the Globus location environmental variables in either profile or user home, okay, or bash profile. So this is the configuring environmental variables. Okay, next security setup. So in this section we use simple CA which is wrapper of open CA functionality. Okay, So in this CA is nothing but certificate authority. So the important thing is, before setting up the certificate authority CA, make sure to synchronize the system time of all the machines in your environment. So this is called the security setup. Next, setting up security in each grid node. So every grid node we have to set up the security. So after performing the steps above, the package file has been created that needs to be used on other nodes. So to describe this, in order to we use these certificates from this CA in other grid nodes, so you need to copy and install the CA setup package to each grid node. So whatever the installations we have done, we have studied in the previous, so the same thing is installed in the other node also. So how many nodes are there? All the nodes, in all that nodes we have to install that same installations. And in order we have to use the certificates in other grid nodes, and we have to copy and install the same CA setup package on each grid nodes. Okay, so this is called setting up security in each grid nodes. So next one is obtain the sign a host certificate. So in order to use some of the services provided by the Globus Toolkit 4, such as grid FTP, you need to have a CA certificate, CA authority signed host certificate and host key in the appropriate directory. So this is called the obtain and sign a host certificate. Next, set mapping information between a grid user and a local user. So what is mean by this? So the Globus Toolkit 4 requires a mapping between an authenticated grid user and local user. So next, configuration of Java WS core. The Java WS core container is installed as a part of default Globus Toolkit 4 installation. So next, coming to usage of Globus. So in this we having client Globus interaction. So what is mean by client Globus interaction? So in this GT4 service, programs are designed to support user applications. So in this user applications, so in this we having the diagram. So there are a strong interaction between provider programs and user code. So the GT4 makes extensive use of Java, okay, Java, C and Python to write user code, okay, to write the user code. The GT4 makes heavy use of industry standard web service protocols and mechanisms in service description, discovery, access, authentication, authorization, and like GT4 makes so the GT4 makes expensive use of Java, C and Python to write user code. So the web service mechanisms define the specific interfaces for the grid computing. So the web services provides flexible, extensible and widely adapted XML based interfaces. So there is a three containers are used in the host user. There are using the three containers that used on the to the host user developed service written in Java, Python and C respectively. So these containers provide the implementations of security, management, discovery, state management and other mechanisms frequently required when building services. So in this we having containers and resource data management, resource or data management. So resource grid resource access and management supports dynamic job executions with coordinated file staging. So MDS is used for monitoring and discovery of available grid resources in the grid execution environment. So whatever the things we are explaining here, so this is regarding this diagram. So the Globus container, we have Globus container here. So a runtime environmental, it is a runtime environmental. A Globus container are also called web service core, core or WS container. In this we provide a basic runtime environmental for hosting the web service needed to execute the grid jobs, and the WS addressing, WSRF and WS notification functions are implemented. uh, So this is called the Globus container at runtime environment. So this is the diagram. Here I having the client. This is the Java client, C client, Python client. So these are the server. This is the client and server. In the server we having some services: Java service, GRAM, so grid resource access and management, file transfer, delegations, index, trigger, communication authentication, data access, telecontrol, Python services, C services, grid FTP, my proxy. Next, second one also my proxy replica. So these are the different services available in the server. In the client we having some clients, that is Java client, C client, Python client. So this is the diagram. So whatever the service needed by the client from the server, so it will be send the request through the Java client. So Java need some information from the server. It will be send the request and it will be access. Okay, so this is the whatever the services needed, they will access from this server. Okay, so they will be communicate with each other. So like unicast. Okay, this is the client. Okay, server sending to the client, and it will be send the request to the again server. So this like the communication will be occurred between the three clients and the server. So next, coming to the another image, this is the Globus container. The main SOAP function performed, the main SOAP functions performed include the transport of incoming job request and corresponding response. So to implement the OSAP commands over the HTTP engine as a message transport protocol and protocol. So both the transport level and message level security is enforced all communications. So the GT4 container can host many services to multiple jobs simultaneously. So the container also so WS container also host advanced services provided by GT4, such as grid resource access and management, MDS. It is used for the health purpose, and services are hosted, and RFT, the application clients uses the the application client uses the Globus container registry interface to determine which service are hosted in a particular container. So the container administration interfaces are used to perform runtime management functions. Web service containers, WS means web service containers, written in Java, C and Python in the GT4. Okay, so next, coming to data management using GT4. So the grid applications often needed to provide access and integrate large quantities of data at multiple sites. We having some following list that introduces these GT4 tools. So first one is grid FTP. So it supports reliable, secure and fast memory to memory and disk to disk data movement over high bandwidth WANs, wide area networks, based on the popular FTP protocol for internet file transfer. Grid FTP adds additional features such as parallel data transfer, third party data transfer and stripped data transfer. So these are the features, additional features which is used in the grid FTP. Okay, and in this grid FTP benefits, we have some benefits in grid FTP from using the strong Globus security infrastructure. for for securing the data channels with authentication and reusability. And it has been reported that grid has achieved 27 gigabits per second end-to-end transfer speeds over some WANs. Okay, so next, the second one is RFT. RFT, it provides reliable management reliable management of multiple grid FTP transfer. It has been it has been used to transfer the millions of files among many sites simultaneously. So simultaneous means at a time, by using the grid FTP, sorry, grid RFTP. RFTP is a reliable management which has multiple grid. In this RFT, we having the multiple grid FTP transfers. Simultaneously we can transfer the millions of files among many sites. Okay, so this is called the RFT. Okay, next, RLS means replica location services is a scalable system for maintaining and providing access to information about the location of replicated files and data sets. So next, fourth one is OGSA DAI, Globus Data Access and Integration. So tools were developed by the UK e-science program and provide access to relational and XML database. So next, coming to MDS services. So in these MDS services, monitoring and discovering are two vital functions in any distributed system. So both the tasks require availability to collect the information from multiple distributed information source. So the GT4 provides monitoring and discovery support at fundamental level. So it contains the two higher level services, an index service and a trigger service, index service. So what is mean by index service? We can configure in hierarchies, but there is no single global index that are provided information about every resource on the grid. So each registration into the index service has a lifetime and requires a periodic renewal of registration to indicate the continued existence of resource or services. So this is called index service. So this is the diagram we are having. So this is the GT4 container. We are having 3 GT4 containers here. So in every GT4 containers we are having the MDS index. So this MDS 4 consists of higher level service and trigger services. We have told what is mean by trigger service. Trigger services is nothing but MDS trigger services collects information and compares the data against the set of conditions defined in the configuration file. When a condition is met, an action is executed. Okay, next, web MDS. Web MDS means what? Web MDS is a web-based interface to WSRF resource property information that can be used as a user-friendly front end to the index service. Web MDS uses standard resource property request to query the resource property data and transform data for a user-friendly display. So this is the explanation of this diagram, and here we are having the adapter. So the MDS index will be accessed through the adapter in this grid FTP, whatever the files needed. Okay, so this is the communication between the container. Okay, next in the next topic we will discuss about the in the next video we will discuss about the main components of programming model. Okay. Okay, thank you.